Okay, in this video we'll be doing a few sample problems, actually 4 of them, for effective yield. Alright, first problem. Determine the effective yield of a $500 mutual fund investment made at the beginning of 2000 that is worth $650 at the beginning of 2010. So we would typically start with the compound interest formula. In this case, P, $500 mutual fund with initial investment. A of T, $650. That's what they told us. T is 10 because we started in 2000, we ended at 2010. That's 10 years. And N is 1 because effective yield N always equals 1. And that being the case, that converts this formula to our effective yield formula. If N was 1, R over N would just give us R, and then 1 times T is T. So we simply substitute this into the formula. There's the 650, which was the A of T, the amount after time has passed, the original 500, and there's our time, 10 years. So in this particular case, we're trying to get R by itself. So we get rid of what's furthest from the unknown according to SATMAP, which is the 500. So we'll divide 500 on both sides. 650 divided by 500, calculator tells us 1.3. Right side, we're still left with the 1 plus R to the 10th power. Now it's time to get rid of this exponent of 10. So therefore we'll be rooting to 10th power, or the 10th root, on both sides. So we got to find the 10th root of 1.3. These, the 10th root, and this exponent of 10, those cancel out, leaving us with the 1 plus R. Simply subtract 1 on both sides, and this is what we'll be typing into the calculator. So let's see what we get. Alrighty. We're taking the 10th root of 1.3. So again, we first have to type the 10 first, the root index. And right there, there's our generic root button. So second 10. So we have the 10th root of 1.3. Move it over so it's away from the vinculum. Subtract 1 on both sides. There's our answer. Now again, effective yield, we're finding a rate. Right now, the rate is in a decimal. We need to now convert it to a percent by simply either moving the decimal 2 places to the right or multiplying by 100. So ultimately, we'll get 2.66 if I rounded it to the nearest hundred. So let's see what we got, 2.66-ish. Calculator first gave us this. We take that, multiply it by 100. There's our 2.66% is the effective yield. All right, a couple more examples. Determine the effective yield of a painting bought for $500 on December 3rd, 1990, that sold for $225 on December 3rd, 1999. Again, we're going to go straight for the effective yield formula. So P is 500 because we started with a purchase of $500. A of T, the amount after time has passed, is only $225. So we lost some money here. And T is 9 because from December 3rd, 1990 to December 3rd, 1999, that's a total of 9 years. So let's just simply substitute everything into the formula. Just like the previous, get rid of this 500 because it's furthest from the unknown. Divide 500 on both sides. Left side, we get 0.45 when we divide these two numbers. We still need to now remove this exponent by taking the 9th root on both sides. There's our 9th root. So the left side, we're left with 9th root of 0.45. On the right side, we'll just be left with the 1 plus R. Simply subtract 1 on both sides, and this is what's gone into the calculator. So let's see what we get here. We don't need this. Let's clear it. So 9 is my root index. Second, and here we are right there again. and 0.45. 0.45. Move the cursor over. -1. All right. Negative. So we should expect something negative because we started with a purchase of 500 and we sold it for much less. So there wasn't an increase, there was a decrease. So we're going to take this number and eventually multiply it by 100 to show our percentage. So ultimately, negative 8.49%. There's our negative number the calculator gave us, multiplied by 100. There's our negative 8.49% is the effective yield. All right, two more problems. Determine the effective yield if the yearly in-state tuition at the University of Georgia for the fall 2010 was $7,500. It has risen to $11,250 for fall 2020. So here's a real life problem. So there's our formula again. We're starting with 7,500. That was the original tuition. After time has passed, 11,250 told us that. And time, from 2010 to 2020, time is 10 years. So again, substitute everything into the formula. There's the amount after time is passed. There's the original amount. Time to get rid of that 7,500 by dividing 7,500 on both sides. Left side, 1.5. Time to remove this exponent, so we'll take the 10th root. 10th root on both sides. Left side, we get the 10th root of 1.5, and we're just left with the 1 plus r. Just like the other instances, simply subtract 1 on both sides, and this is what's going into the calculator. So let's see what we get. We'll clear it first. There's our root index. Second, there we are right there, the 10th root, 1.5. Move the cursor over, -1. There we go. So when we move our decimal over, it looks like it's going to be about 4.14-ish. So times 100. There we go, 4.14%, somewhere around there. So there's our calculator number, multiplied by 100. There's our effective yield, 4.14. One last problem. All right, determine the effective yield if Anaya produced a movie during the summer of 2005, which cost her $1,200. She sold the rights to her movie 3 years later to Lifetime Movie Network for $1.3 million. So let's see what the effective yield is. There's our formula again. Here our principal, the original amount, is the $1,200. The amount after time was that $1.3 million. So I wrote it out, $1,300,000. The time, 3 years, because it says she sold the movie rights 3 years later. So let's just substitute everything in. There's the $1,300,000. There's the $1,200 as the amount we started with. Just like before, this $1,200 is furthest from the unknown, so we'll divide both sides by 1,200. When we divide, left side we get 1083.3 repeating. So it's time to take the cube root on both sides. So the left side we get the cube root of that 1083.3 repeating is equal to 1 plus r. As always, subtract 1 on both sides. So this is what's going into the calculator. Now, there'll be some issues here because how are we going to type in that 0.3 repeating? So what I'm going to type in is actually what I substituted in, I divided to get this 0.3 repeating. So, the cube root, and I'm going to put in not this 1083.3 repeating, but these two numbers divided. I actually could have simplified, but I'm going to put the whole thing. 1,300,000 over, what's that? 1,200. 1,200. Move everything over. There we go. -1. And that way we get a pretty exact answer. 9.27. Now this looks like our final answer, but again, this is just the decimal. we still need to make it a percent by multiplying by 100. So it's actually 927.04%, which is extremely high. But if you notice, you only spent $1,200 on this movie, and you made $1.3 million. Yeah, that's a very high return. So there's the 9.27 multiplied by 100. There's our 924.04% effective yield. All right, so I did 4. Now here's your independent practice. These are the ones you will complete.